Okay, my name's Brooke Cantera. This is GPH 717 Applied Epidemiology, and I'm going to give you a lecture on understanding measures of incidence and association in epidemiology. So measures of incidence. We have risk, odds, and rate. Risk is the number of cases with the disease divided by the total population at risk. So this is really the new cases of disease over the population, the total population, and that's a number between 0 and 1, with 0 being no risk and 1 being 100% risk. This can also be expressed as a percentage if you multiply by 100, so for instance 25% risk. Odds is the probability of the disease occurring over the probability of the disease not occurring. So this is easily looked at by looking at the number of cases with the disease divided by the number of cases without the disease. And it's different from the risk in that you're looking at only the number of cases without the disease in the denominator as opposed to the total population at risk. This number is never negative. 1 is no association, and it's usually greater or less than 1. And then we have rate, which is the number of cases with the disease divided by the population at risk per unit time, and that can be per unit person time, and that can be person years, person days, and then that's times a multiplier. So this is described as the cases per, say, 1,000 person years or 100 person years, and it's between 0 and 1. And it has a different scale than the risk because you're using time in the denominator. So the measures of association now. We have relative risk, the odds ratio, and the rate ratio. The relative risk is the risk of disease among the exposed over the risk of disease among the unexposed. And that's taking the two risks calculated before with exposed divided by unexposed, and you get the ratio of two risks. Then we have the odds ratio, which is the odds of disease among the exposed over the odds of disease among the unexposed. So that's once again taking the two odds used before, and it's exposed over unexposed. The difference here is again that you're using the probability of the event not occurring in the denominator as opposed to the total population. And then the rate ratio is the risk of disease among the exposed over the risk of disease among the unexposed. And the person years or person time unit cancels out here. And it's the ratio of the two rates once again. And all three of these can be greater than 1 or between 0 and 1. They're never negative, and 1 equals no association. Now here's an example we'll be using to help understand these. The example is the data for the incidence of stomach cancer among heavy versus non-heavy drinking adult men in the cities of Atlantis and Camelot. And these are 2x2 tables. So if you look at Atlantis, heavy drinkers who developed cancer was 18. No cancer is 482 for a total of 500 heavy drinkers, and 2 who developed stomach cancer for non-heavy drinkers, and 498 did not develop stomach cancer out of 500 in that group. Same thing for Camelot. And then the person time calculations are already calculated out below. You can get that by taking the number of people times the time period they were at risk, and you add those together. So calculating the measures of incidence in Atlantis, for risk you take the 18, which is the total number of people who developed stomach cancer, divided by the 500, which is the total population of heavy drinkers, and you get 0.036 or 3.6%. And then non-heavy drinkers is 2 out of a total of 500 is 0.004 or 0.4%. So this is the risk of stomach cancer among heavy drinkers is, say, 0.036, and the risk of stomach cancer among non-heavy drinkers is 0.004. For odds in Atlantis, heavy drinkers is 18 over 482. So the odds of stomach cancer among heavy drinkers is 0.037, and non-heavy drinkers is 0.004. So the odds of stomach cancer among non-heavy drinkers is 0.004. And the rate, it's heavy drinkers, is 18 divided by the person years, which was 985 in the previous slide, times the multiplier of 1,000. So you get 18.274 cases per 1,000 person years. In non-heavy drinkers, we got 2 cases per 1,000 person years. In Camelot, the risk for heavy drinkers was calculated to be 0.5. If you take 250 divided by the total population of 500. So the risk of stomach cancer among heavy drinkers is 50%, and non-heavy drinkers is 120 over 500, which is 0.240. So the risk of stomach cancer among non-heavy drinkers is 24%. For odds, heavy drinkers, you got a odds of 1, so that's no association. So there's not a higher odds of having cancer than not having cancer among heavy drinkers. And then for non-heavy drinkers, it was 0.316, so the odds of stomach cancer among non-heavy drinkers is 0.316. And the rate, so heavy drinkers was 250 divided by the person years, 781.25, so we got 320 cases per 1,000 person years. And non-heavy drinkers, 120 divided by 990 times 1,000, so 121.212 cases per 1,000 person years. So now looking at the ratios, calculating relative risk here in Atlantis. So you take the two relative risk numbers we got before, which are at the top there, and it's 0.036 divided by 0.004, which is 9. So the risk of stomach cancer among heavy drinkers is 9 times that of non-heavy drinkers. And then for Camelot, the number is 2.083, so the risk of stomach cancer among heavy drinkers is 2.083 times that of non-heavy drinkers. The odds ratio for Atlantis, you take the two odds, the exposed versus the unexposed, as was shown before. So it's the odds of stomach cancer among heavy to non-heavy drinkers is 9.250 in Atlantis, and the odds of stomach cancer compared for heavy drinkers to non-heavy drinkers is 3.160 in Camelot. And the odds ratio can be used to approximate the relative risk when the disease is rare in a population with less than 5 to 10% of the population having the disease, and when the cases and non-cases are representative of the population, because the denominator is going to approach the same as the risk, because it's going to approach the total population when the disease is rare, so they're going to be very similar numbers. And for the rate ratio, in Atlantis, it was 18.274 we got divided by 2, so the rate ratio is 9.137. The person time cancels out, so the incidence of stomach cancer among heavy to non-heavy drinkers is 9.137 times higher in Atlantis. And then in Camelot, it was 2.640, so the incidence of stomach cancer among heavy to non-heavy drinkers in Camelot is 2.64 times higher. In conclusion, measures of incidence and association can be difficult to comprehend. They're complicated and very complex, but if you understand what you're calculating rather than just memorize, especially because the calculations are not always the same, and talk it through like this, they will be much easier to understand. So thank you.